All right, so let's get started. This is the Exploratory online seminar number 96. Today, I'd like to present what is the right data format for chart and analytics. Actually, like I get these questions a lot. Like when you import the data into the Exploratory and all you want to do is to create charts to visualize the data, or maybe like applying a different analytics to analyze the data. But somehow you can't move into the chart and analytics because somehow the data doesn't seem to be in the right format. So a lot of people get confused, when they start using Exploratory. Not necessarily like just Exploratory, but it's actually like any other type of tools as well. So I wanted to address that and then see discuss like what would be the right format. So then you can sort of like flexibly creating the charts and analytics and then maximize the value of your data. Okay, so let's get started. My name is Kan Nishida, CEO at Exploratory. We started Exploratory 2016 spring. And since then, we've been building Exploratory as a tool and also providing this type of seminar and training to provide more like data science education as well. So, and our vision is that data-informed decision-making is the key to make the world better. So therefore, we like to democratize the data science so that more people can use their own data to gain better insights and make better decisions for themselves. Okay. When we say the data science, we usually use this workflow. Like typically, you start with the business questions, and then if you want to add, it doesn't have to be business questions. You start with the questions of the world, and then if you want to access the data and to answer the questions. But the problem is, it's kind of related to today's topic. The data is not in the right format or right way, so you have to do data wrangling, basically cleaning up the data, transforming the data to the point that like it's enough quality of that you can visualize or analyze the data. Visualization is really like you use a different type of the chart, and analytics is different type of the statistics, machine learning algorithms. Either way, like you're trying to gain the insights by finding the patterns and the trends in the data. And then you go back and forth in these things, it's not in a particular order, but until you find useful insights. Once you find those insights, then you want to communicate with other folks like team members, your manager, or your customers, partners, and so on, so that you can make decisions with your team or other folks together. Okay, so the last communication is also the part of the data science workflow, we think. So the Exploratory is a tool to provide the modern and simple UI experience for doing data access, data wrangling, visualization, analytics, and the last not least, the communication. Okay, so that's it for the introduction. So let's get into the main thing for this seminar. Online seminar number 96, what is the right data format for chart and analytics? So let's say we've got this data, CO2, this is like, actually like I have this data in Exploratory already imported. So this is the Excel data. And I just did already a couple of data wrangling, which is basically, selecting the columns and then change the column names so that it's easier to understand. And then the guy basically did converting the country name because this data originally came in as this kind of country name, but problem is some of the country names are not standardized. So I actually use the conversion from country name, it kind of sounds weird, but from country name to country name. So that, for example, like United States, US, United States of America, US can be expressed in multiple ways, but it can be standardized as United States. And same thing for the other countries as well. And the cool thing about that is Oh, but anyway, so that's what we did. And then like here, like a filter. So I took out all the sort of like NA rows. And then not the NA values, but some of the NA was in the country column. So like I got rid of that. Okay. So now like I have this and then data and ready to go. But the problem is though, if I go to the chart tabs and chart view, and then like, let's say, I forgot to explain what this exact is. So each row represents each country. And then this columns represent each year. So like it's starting from 1965 all the way to 2020. Okay. And then each cell right here under those year column indicating that how much of that CO2 emissions. I think this is like a exajoules or something like that in that unit. But nonetheless, what I want to do here is that like I want to visualize the historical trend. So from 1965 to 2020. And then I want to create those lines for all the countries and see the changes, throughout the years. And then also, like especially, like I like to see like which country is increasing the CO2 emissions, and maybe like decreasing CO2 emissions. Okay, so if I want to do like you go to the chart view, and then let's say like selecting a line chart, and then a y-axis, what should I select? So in exploratory, the x-axis or y-axis is really like it's designed for you to assign a column. So x-axis, you want to assign one single column that holds all the years. Then you can actually create sort of like a time series, a line trend, and sort of like line chart to analyze the time series data. Okay, so the problem is though now is like I have the 1965 as of one column, 1966 as another column. So if I assign this and then that's not it's nothing's going. It's kind of like doesn't produce the one like I want. But like when you see the x-axis, these are actually the CO2 emission numbers, not like years. Obviously, because I assigned 1965. So this is a very common problem, especially you get the data from Excel, and a lot of data were in this format. So what can we do? Okay, so that's the main topic of today. So say the problem is that same data can be stored or formatted in various ways. Okay, so let's take a look at this one. This is sales data. So kind of similar to like CO2 emission data. So each row represent each country. And then the columns, each columns is representing each month. Okay. And then the cells representing the sales number. Okay. So this type of data is called wide data. Why? Well, because the new data, as more new data comes in, then it tends to become wider. So right now, like we have January, February, March. But what happened the next month, like April data comes in? Well, we're going to have another column called April. Same thing for the May and June and July and so on. So the more data it comes in, like that you have more columns means you have wider data. So we call this like wide data. Okay. As opposed to that, you can have the same data in this format as well. Well, what has been changed? Well, now this data has a country and a month and a sales and 3 columns. And then, so the month is a big part here. It's like a month, there is one column. And then the sale value is a January or February or March. Okay. And then, so that means each row not necessarily represent just country. Now it's actually representing a country and also the month, and obviously the corresponding sales value. Okay, so therefore, like we got more rows, less columns, but more rows. Okay, so that means the data is we call long, right? Because the new data comes in, it has a tendency, it tends to have more rows. So like it's increasing in vertical direction. Okay, so like when you get like April data, we are going to have the April rows for those 3 countries. That means we're gonna have extra 3 rows. Okay, so now let's take a look at next. Oh, sorry. So before getting to the next up, so this type of data is probably nothing new to the people, folks who have been familiar with relational database, such as MySQL, Oracle, or whatever, because that database usually the tables are designed to be to not to redesign the schema, because the schema in the database world means like you have to define what are the columns beforehand, before even like start having the data. So you don't want to redefine the column structure every time you get the new data, right? So like it's sort of like you have the fixed set of the columns, but rows can increase or start adding more rows like flexibly. There's no limitation there. I mean, like physical limitation maybe, but conceptually not much limitation there. So relational database has this data. So like if you come from like a BI or a relational database world, this is nothing really new. But surprisingly enough, like you get the wide data if you have to deal with the spreadsheet data, Excel, CSV, sometimes even like a text data, sometimes even coming from like a website, like a scraping data or something like that. Anyway, so we have wide data format and long data format. So which is better? Well, disappointingly, it depends. It's not like one is better than the other. It's just the fact that we have 2 types of data is actually representing the same information. So, but there is something, a difference here. So like that's what I want to talk about next. So there is a concept called tidy data that I like to introduce, because this is actually very important to understand. Once you understand this, and then any data you see, you can judge, oh, this is the tidy or not tidy, and it basically like kind of get to the bottom. So you want to get the tidy data, which makes it much easier to visualize and even like transform and make calculations as well. So what is the tidy data? So tidy data has mainly the 3 rules. Number 1, each variable must have its own column. Second is each observation must have its own row. Third, each value must have its own cell. Okay. So these 3 rules, it's not like I came up with these 3 rules. This is actually defined by Hadley Wickham, who is considered as a father of this concept called tidy data. But also, you go farther back in history, this is actually the concept of the relational database. So there's some similarity in there as well. But nonetheless, so here's the question: what is a variable? What is observation? What is the value? So, let's take a look. So here there's a table. The same data like we saw. So like country column, month column, and sales, right? So we have 3 columns. And each of these columns considered as a variable. Well, what is variable? So country column, inside that column, the same type of data was presented. It's like a US or Japan or UK. You can always consider it as a country, right? So same thing for the months. Months column always have the month information. Same thing for the sales has always, these numbers are always sales, not like a number of orders, not like a profit or anything like that. This is the sales numbers. So variable means it's like the data can be changed, but it doesn't change its nature of the data itself. Okay. So the next one, the second rule of the tidy data is observation. So each row is observation, right? So what observation is like, okay, so like the first one, the US and January, their sales is 2,000. Okay, so and the next one is like Japan, January 4,000. So like we basically observe that event or the data itself, right? So sort of like data points. Okay, so that's the observation. And the third one is the cell, and cell is value. This is kind of like, intuitive or simple enough. Okay. Any cell, then that doesn't have to be numeric cell. It can be US, can be January, whatever that could be. It's just a value of the value, particular variable. And then the last one was sort of like, not last one, sorry, it's like a 3 rules, right? And then this one is kind of like give you the idea, like what is a table? So what is a table is basically a set of the observation. You remember observation is each row. So we have this wide data, long data, which one is tidy, not tidy. So right-hand side is a long data, is a tidy, right? Because each column has to be variable. But left-hand side, when you look at the left-hand side, January, February, March, we can call this as a variable, but the problem is January doesn't mean anything, right? So what are those numbers? 2,000, 4,500. Those are sales number. Okay, so the sales number, okay, so January means it's January sales. And when you look at the February, that's sales too, but somehow presented it in a different column. So now it's like a variable and a column relationship is kind of like broken down. Like now, like 3 columns are representing the one variable, which is the sales, right? And another thing is the January, February, March. These are basically same kind of information, but presented it as a column header or column names. So it's not really tidy. So the right-hand side, in this case, a long data is tidy. Left-hand side is a non-tidy. Okay. So the why tidy data, so because at the beginning I mentioned that already, is that it's easier to visualize that tidy data. And then also not just visualizing it, it's easier to calculate, summarize, filter data. Not just calculate, summarize, filter, but these are the main things that typically like you do as part of data wrangling. So let's take a look why it's easier to do the calculation. So when you have the data like this, we have 4 columns and 4 variables, okay? So this is actually tidy data and happen to be long data. And then we have the sales column, and then we want to calculate total of the sales. Well, if you come from Excel or come from the Exploratory, whatever that tool, you need to do is like use a sum calculation and sum bracket sales that will give you the total of the sales. It's easy peasy. However, when you have the non-tidy data, right, like wide data, how are you going to calculate the total of the sales of the whole data? Well, first, it looks like when you look at the second column from the left, there is a column called measure that has sales and orders. So that means depends on this information, each row's value are different. So like when you look at the January, sometime 2,000, the first row, second one, the 15, and these two are completely different things. One is the sales, one is the orders. Right. So that's super not tidy. I mean, there's no such thing as super or not super, little tidy, non-tidy or something like that. But anyway, so this complicates the calculation because first, we want to focus on the sales, right? Because you remember, we want to calculate the total of the sales. So that means we want to get rid of the orders by using a filter, right? And then you want to actually calculate the whole total value. So we can do is maybe we can do the sum of January, the sum of February, sum of March. But that it gives you the 3 total numbers, like January total, February total, March total. But what you wanted to do is the total of the entire data, right? So what you have to do is like you have to calculate the January and February and March, and you have to add them up to get the total numbers. Okay, so that's a little bit cumbersome. But not only that, the problem is tomorrow. Well, tomorrow or next month, you get the new data coming in. Let's say like April and May coming in. And then you have to update the calculation itself. You remember first we use a sum calculation. When you use a sum calculation, sum bracket sales, then the new data comes in with the next month. You don't have to update the calculation. All you need to do is just sit and then re-import the new data. Boom, like you get a new total number. But here, you have to go back and update the calculation. And that's pretty annoying. So how about like calculating sales per order? So calculating the total itself is annoying or cumbersome, but things get even harder or more complicated when you start asking this type of question. Like, I want to get, okay, I got that sales numbers, but well, there are a bunch of like orders here. So like, I want to see like how many, how much the sales per order, right? So then like you want to do is like when you have the long format or like the tidy data, all you need to do is just sum bracket sales divided by sum bracket order. That's it. That's the end of the story. However, when you have that wide data or like a non-tidy data, you have to do, you remember, you have to filter the data so that you're going to have only sales. And then you have to calculate adding the January, February, March up, right? And then, and then the next thing is like going back. And then this time you have to filter only the orders data and do the January, February, March. And then you have to have those two numbers somewhere. And then like you do the division. So that would be like very cumbersome and complicated. Okay. So again, the long data is much easier. In this case, the tidy data is much easier. Untidy data is not easy as when it comes to calculating or summarizing the data. Okay, how about calculating total sales by country? That's like a super typical thing. Until this point, we just calculated the whole entire total numbers. But how about, I want to calculate by per country, like for the US and Japan, UK separately, right? So in that case, you do summarize. What's summarize? Summarize is actually like you can specify how you want to group that data. So I want to group the data by the country. That means there's a US and Japan and UK. We have the three groups. And then inside, like we apply the same function called sum. And that's it. So that's all we did was on top of the sum calculation, we just added this like grouping information. Okay, if you're coming from Excel, like a pivot table, that's the same thing. If you're an Exploratory user, you use a summarize step to do that. Then add the country to the group by, and that's it. So, and then I'm not gonna go even in there to talk about how you want to do, what if this data was presented in the wide data or untidy data, okay, because it's gonna get way more complicated. Okay, so looks like tidy data is good, and that's great. And then I think the future is bright. But however, the many data in the world is not formatted in tidy data format. Okay, so we should just transform to tidy data, right? And then we should just educate other people. Probably soon, in a couple of years, now we know that what is what with the best right format. So there will be no problem for this kind of stuff. However, I've been in this industry for a long, long time, maybe like 20 more years. And this concept itself is not brand new like yesterday, right? It's been there. However, the problem is most people never heard of this concept of tidy data, okay? And then even they might have heard about tidy data, but still like don't really understand it. So that means we are going to have even more data to be in this non-tidy format, unfortunately. And another thing is, though, it's not just because they are lazy or they are, they don't know anything or something like that. Even if they know, or I know, sometimes me included, me too, that we might store data in untidy format. That's because storing the data is different from analyzing or visualizing the data. Sometimes it's much easier to store the data in a wide data format or untidy format. But when it comes to visualizing it, it's much easier to do a format in a tidy format. But that doesn't mean we want to store the data in a tidy format, because that makes it harder to enter the data, okay, or even like browse the data. So that's another reason we are not going to have a utopia where all data is tidy. Okay, so that says it's important to be able for you to be able to transform untidy data to tidy data whenever it's needed. So, and then, hopefully it's quickly, because otherwise when you see untidy data and then you're like, um, scratch your head, and then like you might want to just go somewhere else, right? So the key is being able to do it and quickly. So that's the part that I like to actually go through by mixing the demo as well. So let's get back to the same data, that emission data. You remember this is CO2 emission data. Okay. And then here we have, go back to the table. And the problem is this is the white data, right? So we want to transform this data to long data. So how can we do it? So it's pretty simple. Like select the first column, like a 1965 in this case, and then you scroll all the way to the column where you want to actually transform from white to long. In this case, 2020. Sometimes this case is like we have only 58 columns. Sometimes you might have 500 columns or 1,000 columns, and you can't really select all of the columns. You don't want to scroll all to the end, right? So in that case, even like you can select it partially. Partial columns is fine. And then what you want to do is like any of the columns is fine. Click on the column header menu and select wide to long, and then selected columns or selected range. In this case, I'm going to use a selected range. Click on that. Selected range, let me select the first column on the last column, and then all the columns between the start and the end as considered as selected. So that's actually convenient, especially when you have like 500 columns or something like that, because all you need to do is select even like a 2 or 3 columns and get this UI, and then you reselect that, you specify what would be the real end columns from here. So this case, like you want to scroll down to the bottom, and then once you do it, then now like I selected the start and end. Okay, and then I'm going to just click run button to show you how that data is going to be transformed. And then now here, what we have is like a country and a country code, and we have a key and value columns. Key columns have the year information. Value columns has the CO2 emission information. And this is actually tidy data. You remember each column represents the variable, right? Each column is a variable. And then this is a CO2 emission variable. And this is a year variable. Okay. So, but we don't want to have like key value. That doesn't make any sense. So you can either rename the columns from here or open the wide to long columns. And then here, new column names, you can set the new column names here. So I'm going to set like a year, and then here the CO2. I think CO2 is good enough. And then click on that. And then not just transforming from white data to long data, but also gives the appropriate column names as well. Okay, so once we get this way, then like we can actually visualize this data the way we want it to do at the beginning. So go to the chart and make sure this chart pin is pointed to the white to long last step, because otherwise you're still working on top of that data before this tidy operation came in. Okay, so now like I have the line chart, x-axis. Now like we have only one column for the year. So I select the year, and I just realized that year is actually not the text, right? It's actually the numeric. In this case, probably okay, but it's actually, I prefer it to be numeric. Otherwise, this sorting order gets sometimes messy, because I want this to be sorted as a numerical value, not the character value, right? So I'm going to just kind of clean that up here before getting the chart. So I'm going to just here change data type from character, where's that? Convert to numeric, and then just click run button. So now this column becomes numeric. Go back to the chart and make sure that this pin button is the last step. And then here is now numerical. Okay, now I don't have to worry about like the x-axis is sorted in a alphabetical order or something like that. And then now the next thing is y-axis. I'm gonna assign a CO2. So this is like a sum. So that means all the countries' CO2 are kind of increasing, except the last few years. Okay. So now from here, what I wanted to do is like I want to actually see this CO2 emission by country and compare. So here, like I want to assign a country. And then basically we have like a bunch of lines, maybe like 100 some lines. And then like we can see, okay, here is the China's CO2 is increasing dramatically, like after like 2005 or something. And the US is actually going downward trend. And then India is also increasing and so on. So this is what the chart like I wanted to see. And from here, like I can start like a formatting or change the column and do the highlight and all that sort of things. But the key is, because now the data is in a long format or the tidy data format, that's why like it's actually much easier to do the visualization or visualizing the data. Okay, let's go to the next topic is transforming long data to wide data. What we have just done is we transformed from wide data to long data, right? And the next topic is the opposite, which is kind of strange. I mean, like, hey, don't we want to make the wide data to long data because the long data is a tidy data and that's always better, right? So, well, it depends. Remember, like at the very beginning, like I said, depends. It's not like one is better than the other. Well, why is that? So when you have like, let's say like employee satisfaction survey, like okay, survey data, and then like we ask a bunch of questions and ask the respondents to select 1 to 5, right? So we get the data like this, okay? And at this point, when you look at this, this is actually a long data, looks like, right? So I kind of, this is a pictured version. The name column, question, and answer. Okay, and then the more questions coming in, the more people's data coming in, and then the data becomes longer and longer. And then from here, like I want to actually visualize it to see, like how many people are answering. Sorry, what is the average of each question score, right? Question score for each question. Right, and then you can assign that question to the x-axis, answer to y-axis, and then like select the mean or average. But the problem is that though there's some little bit problem here, which is like when you want to visualize or analyze the subject level data, not the aggregate level data, to discover patterns in data, that format actually doesn't really help. So if you want to just aggregate, that's fine for creating something like this, right? So like we basically aggregate, in this case, calculate the mean for each question, and that's fine. But something else you want to do, let's say, let me just kind of skip a couple slides here. Something like this, for example, like we want to see like a correlation among these questions. One question is, let's say, my work is important question, and 1 to 5, and passionate about work, and 1 to 5. And what are the relationship between these two, right? Then in order to answer this type of question, then you can't, because this one is like, my work is important, passionate about work, needs to be presented as a different variable. However, we have those variables in the same column, right? So like it's like this one is like a question is a variable, the answer is another variable, because now it's a long data, right? And then so this each row is like an observation, but also it's kind of like a Nancy's first question. That's the each row, okay? And then that means Q1, Q2, Q3, the question 1, 2, 3, like now they're kind of spread out to like 3 rows. But when you think about it though, so the question is a variable, but at the same time, question 1, question 2, question 3 are completely different things. It can be very different things, right? So this time happened to be all of them are scales the same, so like 1 to 5. So it seems like this answer column seems like an answer variable which has the same sort of like characteristics or nature of the questions, right? However, just imagine if the Q2 happened to be something about salary, and Q3 something about the age, and in all of a sudden this answer column numbers can be very different. Because Q1 is a 1 to 5 scale, and Q2 can be like 50,000, 65,000. Q3 is can be 25, 35, and so on. So when you look at the answer column, all of a sudden number doesn't make sense. And you need to actually look at the question column to understand what this $50,000, or even not even dollar, 50,000 means, right? So now this violates the rule of tidy. Each column needs to be a variable, not like multiple variable. It has to be one variable, right? So, but this answer column is not really representing the one particular variable. Okay, so what that means. So this is where you actually want to make this long data to wide data so that each question will be presented as a column. Okay. So now here, when you have this wide data, right? And then that means like new data, let's say like we ask one more question, the Q3, then we will have another column. But we have more correspondence answer comes in. Maybe like next week, the Peter's answer comes in. Then we're going to have longer data, so like go vertical. So it's kind of like a wide and long, and it's kind of like a questionable. But one thing is clear though, is that this is the tidy data because each column is variable, each row is sub observation, like Nancy's observation, Tom's observation, and then that's each cell is a value, right? So this way is actually helpful for some of the visualization, but especially for analysis that I'm going to explain real quick in a quick second. So here, just to summarize, so wide data, long data, but this wide and long is not really well defined. It looks like longer than the other. That's why it's long data. It looks like wider than the other format. That's why wide data. But one thing that's clear, can be defined, is tidy or not. And in this case, wide data happen to be the tidy data. Okay, so let's get back to the employee survey data. So here we have, looks like a long data, but we want to actually convert to wide data. But why are we doing this? Well, because here, what I want to do is, you remember that we want to see the relationship between these two variables or two questions, if you will. And then we see the relationship. I mean, as a correlated, that means the people who gives higher score on the my work is important tend to give also higher score on the passionate about work. That means these two are correlated in a positive way. Okay, so that's the kind of things like I wanted to do, and not only one by one, I want to do all of them. Okay, so one by one means creating a scatter plot like this, and then like one question to be x-axis, another question to be y-axis, and then maybe you can draw a trend line or something and see like what's the correlation coefficient is and so on. However, what if like we have like 5 questions, or maybe 6 or 10 questions or whatever, and if we want to see every single combinations imaginable, right? And then see like where, which of the two has the highest, positive correlation or negative correlation or something like that. Okay, so let's take a look here. What we can do is, let's go back to here, employee satisfaction survey. And this looks like a long data, but we can actually transform this to wide data so that we can actually go to use analytics of the correlation. Okay, so like how we're going to do it. So select in this case, two. Okay, so this is basically the key column. This is a value column. Okay, and then we're going to do is we're going to spread this questions. How many questions here? I'm going to just click on the icon. So there are 7 unique values. So that means I want to create 7 columns. Okay. And then those values will have these corresponding answer values. Okay. So either of the column, and then this time long to wide. And then basically we can see the preview. And as you can see now, each row is ID, each respondent ID. And then we have this like 7 columns created, and it has they have their sort of corresponding values here. And then at this point, I'm going to click on Run button and get basically the data format that we saw in the preview. Okay. Once we get this, basically now we have 686 rows. Okay. And then 686 respondents with the 10 columns. And once we get here, so that we can go to the chart view and start visualizing the relationship by selecting, any of these columns to X and Y and so on. But this time I want to go to the analytics and then create a new analytics and then select the correlation. And then select the variables to be from passionate about current work to like support company's mission. So we have 7 columns selected, and I click OK and then run. What this is going to do is to calculate the correlation coefficient for every single combination. Okay, so then like we can see that, okay, maybe here looks like there is a higher correlation between passionate about current work and consider current job is important. So, okay. I'm not going to go into the detail for the correlation, but this is actually a great way to find which variables are related and so on. Okay. So this is the type of the case. You can apply the run the clustering as well based on how respondents score against these questions. You can find like who are similar to one another or something. So like other types of things too, you can create, do the multivariate analysis and so on. Most of the analytics basically require this format, which is tidy format. Each row is a one subject, observation, but also like a subject. And then each columns are the variables. Okay. So next topic is actually last topic of the day. Is a separate rows to multiple answers. This is actually also some very kind of tidy or untidy related topic, because sometimes when you ask, when you do the survey, there can be like multiple answers, right? So it's not just one answer for the one question. You can select multiple values, right? And then sometimes when you do it, the data comes in this kind of format. Okay, so this data we are going to use is I think this is from a Kaggle, where the data science community, where they compete by creating the better prediction models or providing a better data analysis report or something. But anyway, nonetheless, they ask all the data scientists on the Kaggle and then bunch of questions. And then these are the answers that came back. One of the questions is, what is the algorithm, the machine learning algorithm that you use often at your work when you analyze your data? And these are the answers. So each row represents each respondent or data scientist. But this algorithm column, because this question is multiple answers. Some people say, hey, I use linear regression and then random forest and then decision tree or something. So that means it has 3 values. And those values presented separated by the comma. Okay. So this is this tidy or not? Well, it depends, what type of question you want to ask. But when you focus on this answer of like algorithm or something like that, left-hand side is the data we have right now. Okay. And then when you look at the answer column, is this just one variable? Well, now the problem here is Nancy's A and E, right? Next row is the Tom is E. And are we going to really compare this like an AE person and an E person and a BD? And if that's the case, that's okay too. But the problem is like sometimes like you want to count, just very simple thing. Like we want to do the counting of which algorithms are the most popular. How many people using linear regression versus how many people using XGBoost or something. Then in that case, the format of the left will not help you to answer the question. But if you somehow convert the left side data to right side data, now all of a sudden, in this case, the number of the columns are basically the same, but the answer column has only one value for each row, right? Either A or E or something. So that means now we all of a sudden, like we have 2 rows for Nancy or 3 rows for Patricia because she selected 3 values or 3 algorithms. However, we can do the calculation of just simply counting for, like how many people the A, how many people selected B, how many people selected C, and so on. Okay, so basically that's sometimes what you want to do. In this case, is like, again, it's not like left side is better than the right hand side. It really depends what you want to do. You want to do the counting in this particular case, right side data is better than the left hand side data. But you want to do something like this: how many people are here, or like maybe sorry, yeah, how many people are here? Just counting on the left-hand side name will give you that answer right away. However, you can actually do that on the right-hand side data to count a unique value as well. But nevertheless, the point is depends. And this time, like what I want to do is when you go back in here, let's open this Kaggle survey data. Okay, and then each row represents each data scientist or respondent. And then here's the algorithm. So for the first row, like a dense neural network and a convolution network and a recurrent network, so it has 3 values. But I want to know like how many people said, use dense neural networks, and also like how many, compared to other, like what is that, like, the most popular algorithm or something, right? So in that case, we can't do it with this data format. So therefore, from here, not like wide to long, in this case, separate by the columns. So that means the first row has 3 values, and those 3 values I want to transform into the way that they are presented in the 3 rows. So instead of separating the columns, I want to separate to rows. Okay, so here separated to rows and separate by comma in this case. And then I'm going to just click on Run button. And then now the first one, the responder number 4, has 3 rows. And then these 3 values being now transformed into 3 rows. Okay. Once we get this, and then I don't even have to go to the chart at this point. I can click on this eye icon and see the number of the people who say linear regression or decision tree and so on. Here, obviously, linear and logistic regression, we have 5,790 people, and this is the most popular. Next one is the decision tree and then random forest. This is the second popular, right? So as long as each value is presented in each row, then we can calculate like this. And obviously, not just for this information icon, I can go to the chart and then create a bar chart, or maybe create a pie chart, whatever the chart, to see the ratio or sort of like a top ranking or whatever the thing I like to do or you like to do. Okay. So this way, this to be for that particular reason, I think to me, this is like more tidy because this column is now the variable and then the change value, right? Not like, when you have the column separated 3 or 5 values, I'm not sure like how the value change between the 5 to 3 column separated values, but here is obvious. Each row is like a different name or different value. Okay, but the if you get confused by like what is tidy, what is not tidy, it really depends, what you want to do. The key is that there is a tidy data that is, can be wide, can be long. In this particular, the first data we started with, the long data to be tidy. However, the second or third data we are using, second data, the survey data, the wide data was tidy. So it's not like wide or long, which one is better than the other. It's really about the tidy or not tidy. And the most important thing is either way, you can transform the data, hopefully to tidy data. But even like if it's untidy or tidy, as long as you can visualize it or you can run the analytics, there's no problem if it's untidy or tidy or not. Like just forget about it. But tidy data tend to help you better when it comes to visualizing or analyzing data. So when you get confused or when you get sort of like, hey, what are you gonna, the question of like, hey, how can I work with this data? Think about your data is tidy or not. And that question helps you to figure out what's the next step, how you want to transform the data. Okay. That's it for today. And after this point, I like to, we've been doing this online seminar every week. So if you're interested in the future schedule or the past recording, go to our website, exploratory.io, and then go to Learn and then Training Seminar, and then go to the online page. At the bottom of the page, click on the check out the past seminar, and then you can see all the seminars we have done in the past and recording. And also, if you happen to be the Exploratory users, go to Learn, and then under that, how to tutorials, how to video, and also chart gallery that lists a whole bunch of different types of chart and chart features of like how to use those features type of notes as well. Another thing is we are opening the application for data science booster training. We are planning to do it like in November, middle of November. And this training is 5 days, and then holiday training. Each day we have a 2 hours class online, and then so in total 10 hours. And starting from like a data basic and then visualization, statistics, and then machine learning or prediction model, and so on. And then the key thing here is anybody's welcome. There's no prerequisite for a data science or data analysis or statistics and so on. We're going to start from the beginning. So as long as you like to learn how to use data science, various data science methods in the real world business scenario. And what you need before training is, okay, I think it's better to be able to use Excel just to do simple calculation or being, able to do the sum calculation. And that's pretty good enough. And also, you need to be familiar with Exploratory as well, because we're going to use Exploratory as a UI tool to accelerate or make it easy to learn the real contents of the data science itself. So, but if you haven't used Exploratory, you're not familiar with Exploratory, don't worry about it. You want to just commit 1 hour tutorial and to, play around Exploratory, and that's more than enough. And then the really key thing is that if you're curious about the data, you have the desire to learn, to understand data better. And here's the schedule from the Monday to Friday. Like I said, each day has 2 hours, and starting from data basic and visualization. We're going to cover the data wrangling, like the thing that we did today, but it's something more like starting from the basic as well. And then all the way to like multivariate analysis, clustering, text analysis, time series forecasting as well. Okay. So the good news is the early bird discount is happening right now. So if you're interested in, or if you know somebody who might be interested in, please apply before September 30, then get the 10% discount. And if you happen to be a student at schools, either high school or college, university, whatever, and then you can get not only the early about 10% off, but you have the student discount, which is 50% off. So in the total, you pay $222 if you apply before September 30. Okay. So please take a look at our page. I think if you go to here, our website, and then under the Learn, go to Training Seminar. And then you have the, you click on this detail page for the training. And then you have more information you can take a look at. Okay. Hope you can sign up. Or if you have any question, please let me know. And otherwise, I think today's seminar is that's it for today. So if you have any question, please feel free to reach out to me at kan@exploratory.io. And we also have the Twitter or the X account called Exploratory Data. That's where we make announcements about like our events, including a seminar and training, but also we post like how to, use type of the contents as well. So it's pretty useful account, I think. And then also our website is exploratory.io. That's where you can find a lot of exploratory related information or data science related information. Okay, so that's it for today. Thank you so much for joining. And the next week, we are planning to another seminar on Wednesday at the same time. So hope to see you there as well. Otherwise, hope you're going to have the great rest of the week and hope to see you soon.